Hello, welcome. Thank you for listening in on me. My apologies for not being present at the conference right now. You can only listen to this pre-recorded message, as right now I will probably be hiking somewhere in Scandinavia, which in fact beats sitting at a computer for me, so thank you very much for taking over that task. My name is Patrick, and I've learned to be critical about what people call AI, or what researchers call machine learning. I've been working with neural networks since my master's thesis in the late 1980s, and later on my PhD thesis in the 1990s, and several jobs in research institutes and universities I've had since then. And I'm enjoying the new interest in this field that we've seen in the last, well, let's say 10 years or so. But at the same time, I know there is a very, very long research way to go. I think we are only at the very, very beginning of what machine learning can do for us. And the reason for that is the following. The current success of applications of machine learning is to a large extent almost exclusively based on supervised learning. And that means that neural networks or similar technologies learn from the data that are annotated in most cases by people. So in most cases, you will actually have people sit down and create data sets from which a system like this can learn what's what. Like in the example here, you have annotated images of cats and dogs. And it's actually for these kind of fields, like images or language, it's not all that hard to create these data because you can do crowdsourcing and many examples are available. But it certainly does not scale to other domains, like in control or things involving machines. The problem of these methodologies is that you need many, many data to have these standard machine learning methods work. And that's because they are based on the central limit theorem. And the central limit theorem says that any data set which is infinitely large has a Gaussian distribution, a standard normal distribution, which is at the heart of the mathematics of these methodologies. So this assumption holds for a large enough data set. If your data set is large enough and a nicely annotated data set, then you can use that to train a standard neural network quite well. But in most cases, of course, it isn't, and you don't have these. Nature does that very differently. Animals do this differently. We do this differently. We can all do this. We can control and navigate in very, very complex environments by learning the relationship between our actions, between what we do, and our observations, what we see, what we hear, what we feel. Our brain learns to predict what we will see, what we will experience, based on the actions that it plans to execute. So it learns a simulation, basically, of what our sensory inputs are going to be, and can play that simulation based on planned actions. And that, of course, also includes the actions of the environment. So, well, neuroscience calls this predictive coding, and it's actually key for survival. And importantly so, it is learned without a teacher. So we don't need to have an external entity, an external teacher, which tells us what to do in a specific action. But our brain learns that from experience. In my lab, which is a fundamental research lab on machine learning and control at Volkswagen Group in Munich, we are trying to do the same with unsupervised learning and optimal control. Basically what we do is we learn neural network representations, internal representations, of dynamics of a system in terms of its sensory inputs. And the scheme you see on the slide depicts that. And if you look at the Z symbols over there, those Zs are internal representations of the observations X. And look at sequences of data. The arrows in the picture are in fact neural networks. And each of these neural networks, 3 in total for each time step, are trained unsupervisedly. They don't need a teacher. They just need to observe the environment, the data that comes in through the sensors, and the actions that are taken by the system. All of that is unsupervised learning, optimal control, and in deployment, the system runs just on local small computers, Raspberry Pis, on those drones. We do that in different settings as well, like in this example. Here we use the same system to learn navigation in an unknown environment based on sensor readings only. It actually learns a map from the environment. It's put into the same kind of probabilistic neural network as you've seen before. And then we can use the information that is coded there on the position of the agent and the uncertainty in that position to, for instance, plan a route or to know where to find new information, where you should go to find the next information that you're missing. So even though all of these systems are still in the beginning phase and we are not very close to general deployment, but that will certainly come. So perhaps with these systems, we will be moving closer to something like general artificial intelligence, more closer to what in biology you will find as intelligent behavior. But if that happens, do we actually need to worry? Or should we be worrying about machines becoming smarter than we are? Of course, machines have always been smarter than we are in many singular tasks, and we should really think in each and every time about the implications of that. Comparable to how mobile phones change our life, machine learning is already beginning to do that in even a more impactful way. Example, it can go wrong, of course. Look at this. This is a very well-known example from 5 years ago. Google image recognition software then mistook black people for gorillas. And for a very simple reason, for somebody who knows how the system works, because the data set that were used to train these neural networks simply contained too few images of black people. So Google couldn't fix that immediately. So what they did initially is to remove the class gorillas out of their image recognition software. And that solved the problem on the surface. But to really solve it, it took them actually 3 years to fix that. Important message here is, how do you actually recognize such problems? How do you see that these problems actually exist before they become problematic for society? There are many other examples. This is just a small excerpt of them. For instance, Microsoft, which put a chatbot online, which learned from people interacting with it. And of course, it didn't take long for people to feed it with racist and other hate speech. And that was very quickly put up by the chatbot, and so Microsoft had to take it offline. Or gender bias in images is a big issue, right? Many of us are, of course, raised with some bias, and that's reflected in the data that we use to teach a neural network. So, in that, the system learns to copy us in mislabeling, for instance, in this example, a man in a kitchen as a woman. And that's maybe not a very important thing, but it can have very important side effects as well. For instance, when Amazon tried to train an automated human resources tool on their previous hires, well, of course, it copied the bias that was in there in favor of hiring only men. But not all failures are based on unbalanced data sets only. Another example, the 2018 Uber crash, for instance. This error was to a part caused by engineers which changed specific safety features in the system to improve a demo for stakeholders. And apart from these things which are hard to recognize immediately before they occur, there's of course also the issue of misuse. How can we safeguard such wrong use? Well, it's nothing new to think about that. As an example, here's a picture from a recent publication from Thilo Hagendorf approximately a year ago, listing AI ethics guidelines that are out there. It's a large number that you see there. And that's wonderful that so many of these exist. But the problem is that these are not accountable or mentionable. They're not actionable. So what do you do with such a set of guidelines? How do you actually take those things into account, that you do want to do good and do want to use your algorithms for good causes? But what does it mean for you as a researcher? What does it mean for you as a programmer, as a developer, as a deployer? Indeed, despite of all of these measures of goodwill, despite of all of these ethics guidelines, things still go wrong. This is an overview we made approximately a year ago, and it's far from complete, but it just gives you a demonstration that the number of initiatives of goodwill and AI ethics increases, but at the same time, the number of ethical concerns does as well. So how can we solve that problem? I think it needs to be addressed very acutely. First of all, finding a set of ethical guidelines is needed to start off with. And indeed, those exist. As an example, those by the HLAC, the high-level expert group on AI of the European Commission, or of the OECD, or of the UNESCO, or many others. These can be used, are ready to be used there. So you don't have to reinvent the wheel. But then, secondly, those guidelines need to be made actionable. We have to make them measurable. What do these guidelines mean for my department? What do they mean for me as a coder, as a developer, as a researcher? What do I actually do with those? And once I know that, how can I actually measure that impact? How can I measure how my department deals with these issues? So, in short, we need to make these measures, these guidelines measurable and certifiable. And thirdly, of course, we must go to a situation where we can create trustworthiness by design. Ethics, you shouldn't forget that, also has an impact on research, on machine learning research. And it's a positive one, I'm sure, because ethical concerns makes us researchers be more conscious about new algorithms and how to make these stand up to scrutiny. So we've set out to do that. We created an organization which is working on exactly these issues. The organization, it's called ETAMI for Ethical and Trustworthy Artificial and Machine Intelligence, started early this year, and it takes the 2019 HLAC report and the OECD and UNESCO recommendations as a starting point, and it evolves these into measurable and actionable items. And then it looks into certification. So to get this momentous task solved, we decided to set it up as an independent organization, and we invited several European companies and universities to join us in developing this path. You can see a list of partners here. It's a total of 40. Fitting in the landscape, ETAMI currently is just setting academia and companies working on standardization and auditing. Now, of course, we've had a bit of pause in the last months as everybody, but we've restarted now with these companies and universities and have planned the rest of the project. Right now, we've set up the organization and planned what we're going to do and who of the currently 14 partners are going to do what. And that is by first making ethical compliance measurable, then testing and validating those guidelines, and finally implementing a certification roadmap. So the first part, the measurability and the standardization, we are going to have finished by the end of this year. And early next year, we will have those results for you, and we will start piloting our companies with these methodologies. And once it's done, we will of course open source everything we have produced. as I do in my lab, because open sourcing, in my opinion, is the only way to bring knowledge in our society forward. And finally, we will then move towards certification. So in a year from now, Itami will be rolling out a path towards certification of trustworthy AI. And this is the only place where I actually like to use the term AI rather than machine learning, through its partner companies. Itami will then go towards standardization and certification. And I think Itami can do this because it started from an open source research lab, my lab, which is placed in industry, and bridges thus between academia and companies. Of course, Itami will be inclusive and open to other companies and universities joining, because I think this is an issue that we must address together in order to make sure that no stupid mistakes happen, but at the same time that we can continue our development and deployment of these very important methodologies. As always, I'm of course very happy to engage in a good discussion on machine learning research, about ethical and trustworthy AI, or about deployment. Yes, and in the end, I'd like to give a short commercial. At the same time, we are doing something rather differently, is looking into how machine learning can be deployed for the development of the solution of the SDGs, the Sustainable Development Goals of the United Nations. So what we've done is we've teamed up with Microsoft and started the initiative 10 to Go, which will take place in an event end of February in 2021. And at that event, we will invite 100 people to join in developing methodologies based on machine learning, based on data, to tackle the SDGs. And the winning team will be awarded €100,000 to make their methodology come to life and remain sustainable. Thank you very much, and enjoy the rest of the conference.